Hi, Bobcats. Chapter 8 starts our study of oxidation and reduction reactions. This is one of those weird things where if you say the whole words oxidation and reduction, usually we say them in that order, but usually this type of chemical reaction gets shortened down to redox. So reduction comes first and then oxidation, and it gets all crunched down to just redox. So we'll be studying redox reactions in this chapter. Our objective for this video is to be able to look at what we call an unbalanced half reaction and determine, is that an oxidation or is it a reduction? Oxidation and reduction are reactions that always go together. They're two halves of a whole. This is because oxidation and reduction involve a transfer of electrons. The species that gets oxidized gives away one or more electrons, and the species that gets reduced accepts those one or more electrons. And so it always has to go together because one element's giving away electrons and the other element is accepting them. But it's usually easier for analyzing these reactions to consider the oxidation separate from the reduction. And so we break the chemical reaction up into two half reactions. Just remember that wherever you have an oxidation, there also has to be an accompanying reduction. I really like the graphic on this slide because it talks about 4 different ways that you can identify oxidation and reduction. Depending on the particular reaction, one or the other of these 4 ways will be easier or more obvious when you look at it. So it's nice to keep these 4 things in mind. So the first one of these involves oxygen, as we see right here on this top where it's like sort of an orangish color. The oxidation process, if we're watching oxygens, means that you gain oxygens as the reaction proceeds. So since reduction is the opposite of oxidation, it means that you're going to lose oxygens. In terms of reduction, hydrogen acts like oxygen does for oxidations, in that if something gains extra hydrogens, it's going to be considered a reduction reaction, and if it loses hydrogens, it's an oxidation. Those 2 criteria, oxygen for oxidation and hydrogen for reduction, are helpful at times when you can look at the chemical reaction and you can see, oh, on the left-hand side, I had this many oxygens, but on the right-hand side, I had 2 more. Therefore, we gained oxygens. It must be oxidation. But you can have oxidation and reduction reactions that don't involve oxygen and don't involve hydrogen. And so we've got to have something that's a little bit more general that will work for other types of chemicals. So oxidation and reduction at their fundamental level involve the transfer of electrons. The species that loses those electrons gets oxidized, and the species that gains the electrons gets reduced. Now, it can be difficult and time-consuming to try to go through and say draw Lewis structures or do something to keep track of all of those electrons and how they're being transferred. So there's a formalism we're going to introduce. It's called oxidation number, which is down here in this last row. And with oxidation number, there's going to be a set of rules for assigning the oxidation number to any element in a compound. And then if that oxidation number increases, we're going to call that an oxidation reaction. But if the oxidation number decreases, we're going to call that a reduction. And that's actually how I usually remember that one. If the oxidation number is reduced, I usually use the term reduced instead of decreased. If you reduce the oxidation number, it's a reduction. Now, when my class meets face-to-face, we usually use these next several slides to kind of go through identifying these. So I'm going to kind of walk through these with you, and I'm going to ask you at times to pause this and figure this out for yourself before going on to listen to the answer. So the first one of these, we've got KClO3 yields KCl, and we need to decide if this is an oxidation or a reduction. Well, when you look at this over here on our reactant side, we're starting with 3 oxygens. And over here on the product side, we have 0 oxygens. So we've lost oxygens. When you lose oxygens, that's considered a reduction reaction. Now let's take a look at that chart. Right, so what was happening here on this first one was we were at this point. We were losing oxygens, and so that's a reduction reaction. Now how about this one? PB goes to PbO2. I want you to pause the video, take a moment, and decide for yourself, is this oxidation or reduction? Okay, so pause now. All right, if you started replaying after making your own decision, hopefully what you noticed was we went from 0 oxygens on this side to 2 oxygens on the product side. So we gained oxygens, so that means this one is an oxidation reaction. In this next example, the number of oxygen atoms stays the same. There's 1 oxygen on the left and there's 1 oxygen on the right. So we can't use oxygen to decide if this is an oxidation or a reduction. And so let's see what else we have going on. It looks like the thing that changes from the left to the right is that on the left we have 6 hydrogens and on the right we only have 4 hydrogens. So we lost some hydrogens, which is going to make this an oxidation reaction. And once again, here's that chart. What we did was right here, we lost hydrogens, which makes that an oxidation. Also, I wanted to point out that when we're looking at these half reactions, these are absolutely unbalanced. I didn't want to throw in the rest of the stuff that we have to throw in to balance these because I didn't want to confuse you. I wanted to have this focusing just on the most critical part of these reactions that we would use to make this distinction. Okay, here's our next one. C2H2 yields C2H6. Pause this video and decide for yourself, is this an oxidation or is this a reduction? Okay, hopefully you paused it, and notice that in this reaction we're going from 2 hydrogens on the left to 6 hydrogens on the right. So we increased how many hydrogens there were, which is over here we're gaining hydrogens, so that makes this reaction a reduction. All right, last round of these clicker questions. We have the chromium 6 ion plus 3 electrons yields the chromium 3 ion. Is this an oxidation or a reduction? Okay, well, the way I look at this one, we've got 2 ways we can answer this. One is to look at the oxidation numbers. I know I'm jumping ahead. Oxidation numbers on ions are their actual charge. So +6 is the oxidation number on chromium, and +3 is the oxidation number on chromium over here on the product side. So we go from +6 on the reactant side to +3, excuse me, to +3 on the product side. Since we reduced the oxidation number, this is a reduction reaction. Now, there's another way that we can determine that, and that's because we are adding electrons to make this reaction go. So we start with this chromium +6 ion, we add 3 electrons to it, and that gives us the chromium +3. So we also added electrons. So if we go back and look at this graphic, if we gain electrons, and that's going to be a reduction, and that accompanying decrease in oxidation number also makes it a reduction. Now, for our next question, what about sulfur -2 yields sulfur neutral plus 2 electrons? Okay, pause this for a moment, decide for yourself what it's going to be. Okay, so we have sulfur with a -2 oxidation number turning into sulfur with a 0 oxidation number. If there's no charge written, its charge is 0. So -2 increases to 0. So that means we're increasing the oxidation number. And then the other thing, we're starting with this S-2 species, and we're we're ending up with sulfur plus 2 electrons. So that means we, excuse me, we removed these 2 electrons from the sulfur. We lost those electrons. So that increase in oxidation number of -2 going to 0 corresponds to this loss of 2 electrons, making this an oxidation reaction. Okay, Bobcats, our objective for this video was to be able to look at one of these unbalanced half reactions and identify it as either oxidation or reduction. We looked at several different ways to do that. If it gains oxygen, it's oxidation, but if it gains hydrogen, it's the opposite, it's reduction. If the oxidation number increases, it's oxidation. If the oxidation number is reduced, it's a reduction. And then we also looked at, in terms of electrons, if it gains electrons, it's a reduction, and if it loses electrons, it's an oxidation.